Have you ever just stopped and wondered how all those simple electrical signals firing inside your brain, billions of them, somehow create the world you're experiencing right this second? It's one of the biggest questions out there, and today we're diving into how consciousness might actually emerge from the physical stuff of our brains. I mean, that's the fundamental mystery, isn't it? We've got these incredibly basic building blocks, neurons that just fire on or off. But somehow, from that simple binary, they build, well, everything. The color red, the feeling of happiness, a complex thought. In this explainer, we're going to look at two very different maps that try to chart that incredible journey. So, here's how we're going to tackle this. We're going to climb what I'm calling ladder of consciousness. We'll start with the simplest possible signal and build our way up, step by step, all the way to complex thought. We'll check out what's happening on each rung, and then we'll wrap up by comparing two really different views on how it all works. Right, so this climb is going to have two guides. On one side, we have the mainstream neuroscience view, built from decades of amazing research into neurons and brain circuits. And on the other side, we have a newer, more out there idea called the Brain Kinematics Model, or BKM. It suggests consciousness isn't about single neurons firing, but about the physical, wave-like patterns that actually flow through the brain tissue itself. These are the four big rungs on our ladder. We kick things off with sensation, just a raw blip of information. Then that blip becomes a real, recognizable object in perception. Next up is feeling, where we attach some kind of emotion to that object. And finally, we hit cognition, the world of abstract thought. And the cool thing is, each step is built right on top of the last one. Okay, let's start the climb. Right at the very bottom, the absolute foundation. This is the moment a photon of light hits your retina or a sound wave vibrates your eardrum. How does that physical thing out there in the world become something your brain can even start to process? And that first step is sensation. You can think of it like a translator. It takes the language of the physical world, light, sound, pressure, and converts it into the brain's native tongue, which is all electrochemical signals. Now, at this stage, it's totally preconscious. You're not aware of any of this yet. It's just raw data hitting the system. And right away, we hit a major fork in the road. Mainstream neuroscience says the brain acts like a detective, breaking the signal down into tiny little fragments, things like edges or colors or tones. The BKM, on the other hand, sees the brain's cortex more like the surface of a still pond. The signal isn't a clue to be analyzed. It's like a pebble dropping in, creating a tiny ripple, a local strain disturbance that just gives the brain this very primitive sense that, hey, something is there. All right, moving up to the next rung on the ladder, we've got these raw signals, these fragments or little disturbances. So how does the brain actually assemble them into the stable, whole objects we see all around us? How do all those pixels become a clear picture? This is perception, and this is where the magic really starts to happen. It's that incredible step where all that scattered data gets woven together into something meaningful. It's the difference between seeing random splotches of color and actually recognizing your best friend's face. This is where a conscious picture of the world truly begins to form. And the two models have fascinatingly different ideas about how this happens. Neuroscience talks about recurrent processing. Imagine different parts of your brain are in this constant looping conversation, refining the data until it's solid enough to be broadcast across what they call a global neuronal workspace. But the BKM imagines something totally different, fractal synchronization. Think of it like this. Your brain is like a room filled with thousands of tuning forks, all your memories and past experiences. The new signal comes in like a sound wave, and only the tuning forks with the exact matching frequency start to hum together. That synchronized vibration is the perception. Okay, so we've perceived an object. Let's say it's a spider. We don't just see it as a neutral thing, right? We feel something about it, maybe fear, maybe curiosity, and we can think about it. So how do we get to these higher levels of feeling and thought? So where does that jolt of fear come from? The neuroscience view says our feelings are basically a best guess. Your brain sees the spider, it checks in with your body, heart racing, muscles tense, and it infers, okay, this must be fear. The BKM, though, has a much more physical explanation. It says that the spider perception, that humming resonant pattern, couples up with old fear patterns stored in your brain. And this creates a literal physical push or pull in the brain's field, a strain gradient that you experience as that feeling of get away or, ooh, interesting. And that brings us to the very top of the ladder, abstract thought. And what's interesting here is that both models kind of describe a similar result, just using different machinery. For neuroscience, it's about global broadcasting, taking an idea and making it available to the whole brain for planning and reflection. For BKM, it's about creating a big, stable circulating pattern, a strain flow, that lets you mentally play with ideas. But either way, it points to this massive brain-wide integration. So we've climbed the ladder all the way from a simple signal to a complex thought. But what's the engine that powers this whole thing? What gives our consciousness its depth and its feeling of being a continuous story? Well, it turns out it's not just about what we see, but about what we do. This is such a great way to put it. Our conscious experience isn't some movie we're passively watching. It's something we are actively building, moment by interacting with our world. Our actions, our movements, they are a crucial part of building the reality we perceive. And on this point, both models pretty much agree. Neuroscience shows that actively exploring, moving your eyes around a room, creates a way richer and more stable picture than just staring blankly. The BKM describes this as your motor commands creating a stable cycling wave in the cortex. This constant loop is what makes the experience feel deep and gives it that story-like flow. Actively playing the game makes the world feel more real. And this, right here, this gets to the absolute heart of the whole debate. Neuroscientists have noticed for a while that our brain signals have these weird fractal-like properties. And the more complex they are, the more conscious we seem to be. But are those fractals just a side effect, a correlation? Or, as the BKM argues, are they the actual mechanism? Are the fractal dynamics the engine that produces consciousness? Okay, let's bring this all home. We've climbed the ladder using two different maps. Now it's time to stand at the top and really compare the views. This table just lays it all out so clearly. Look at the basic units. Neuroscience starts with what we know, neurons, synapses. BKM starts with these much more abstract ideas of strain packages and memory fractals. Or look at perception. For neuroscience, it's a conversation. For BKM, it's about things vibrating in harmony. But really, it all comes down to that last line. Is the fractal nature of our brain activity just an interesting feature that happens to go along with being aware? Or is it the very thing that generates awareness in the first place? And that leaves us with this incredible question to ponder. Is your inner world the result of a winning piece of information being broadcast across your brain like a news flash? Or is it something more like a symphony, with countless patterns all vibrating together in complex, resonant harmony? The science is far from settled, but just thinking about these two possibilities really gets us closer to understanding the absolute miracle of our own minds. Thanks for joining this explainer.